Good morning, learner. Today we will learn about satellite communication advantage, disadvantage and application in this session. Welcome to the fascinating world of satellite communication. Before we proceed into the details of specific advantages and disadvantages and its application, it is important to understand what satellite communication entails and why it is such a pivotal technology in today's interconnected world. What is satellite communication? Satellite communication involves the use of artificial satellite to provide communication links between various points on Earth. These satellites act as a relay station in space, receiving signal from a source on Earth, amplifying them and then retransmitting them into desired destination. This technology is crucial for a variety of applications including television broadcasting, weather forecasting, navigation, military operation and global internet connectivity. From the historical context, the journey of satellite communication began with the launch of a first artificial satellite Sputnik 1 by Soviet Union in 1957. This event marked the dawn of the space age. Since then, the technology has evolved rapidly, leading to the deployment of sophisticated satellites that form an integral part of our global communication system. Importance of satellite communication. Satellite provides several unique capabilities that are not easily achievable with terrestrial communication system. They can cover vast geographical areas including remote and rural regions, where terrestrial infrastructure is either non-existent or economically unfeasible. Satellites also play a crucial role in global broadcasting, disaster management and providing connectivity during emergencies. Now, coming to the satellite communication advantages. A very first advantage of satellite is wide coverage area. Satellite can cover a large geographical areas including remote and rural regions that are difficult to reach with terrestrial infrastructure. This is especially beneficial for providing communication services in very widely populated or hard access areas. Let us understand this advantage with an example. The example discuss about calculation of coverage area of a geostationary satellite. The problem statement is like this: for geostationary satellite, determine the coverage area, that is also called footprint of satellite on the earth surface, assuming satellite can cover an angle of 17.5 degrees in all direction from its position. So, let us begin with the Kepler's third law. Kepler's third law says that T square is proportional to A cube. T is the orbital period and A is semi major axis. You can see this formula where it says T square is equal to 4 pi square divided by mu into A cube, where mu is product G m, where G is gravitational constant, it has a standard value, and m is mass of earth, that has also standard value, and for geostationary satellite T is approximately 24 hours. Now, putting these values in the Kepler's third law, we can find out the approximate value of A, that comes out 42,214 kilometers. Now, let us calculate the coverage area, and we will remember that the angle of coverage, that is also known as in satellite technology beam width, that is also known as footprint angle, field of view, or also coverage angle. Now, converting the angle of coverage theta from degrees to radian. So, theta equal to 17.5 degree into pi by 180, and from that we will get theta in radians, that is 3.305 radians. Then we will calculate the arc length L of the coverage area. So, L will be equal to A into theta, and this comes out approximately 13,000 kilometer. Now, determining the area A of the coverage footprint, and we are assuming roughly that area is circular. So, we can use the formula A equal to pi r square that we are using for circle, and from this, right, we need L for this formula. So, r is equal to half of the L. So, we will get r and we will put this value of r in the formula of A. So, this gives the approximately the coverage area. So, the coverage area of geostationary satellite on the earth surface is approximately 13 crore square kilometer. This numerical example demonstrates how the semi-major axis calculated using Kepler's law helps determining the vast coverage area of a geostationary satellite, highlighting one of the significant advantage of satellite communication. Then another advantage is long distance communication. Satellite facilitate long distance communication by relaying signal over vast distance without the need for extensive ground based infrastructure. This is particularly advantageous for international broadcasting and global communication network. Broadcast capability. Satellites are ideal for broadcasting services such as television and radio, as they can simultaneously transmit signals to the multiple locations across the large area. This makes them essential for DTS services and satellite radios. Then another advantage is mobility and flexibility. Satellite communication provides mobile and flexible communication solution, making it possible to establish connection in mobile platforms like ships, aircraft and vehicle. This is crucial for maritime and aviation communication system. Then another advantage is disaster recovery and emergency communication. In the event of natural disaster or emergencies, when terrestrial infrastructure may be damaged or destroyed, satellite communication offers a reliable means of maintaining communication link. This is vital for disaster response and recovery operation. Then global internet connectivity. Satellite play a key role in providing internet connectivity to unreserved and remote areas, helping to bridge the digital divide. The LEO, that is low earth orbit satellite constellation in particular are being deployed to offer high speed internet access globally. Redundancy and reliability. Satellite provides an additional layer of redundancy for communication network. In case of failure in terrestrial network, satellite communication can serve as a backup and ensuring continuous and reliable communication services. Another advantage that is very crucial is security and surveillance. Satellites are used for secure communication in military and defense application. They also enable surveillance and reconnaissance operation, providing real time data and imagery for strategic tactical purposes. Environmental monitoring and weather forecasting is another advantage of satellite communication, where satellites are essential for monitoring environmental changes and weather patterns. They provide critical data for weather forecasting, climate study and disaster preparedness, contributing to better understanding and management of natural phenomena. Telemedicine and remote education. Satellite communication facilitate telemedicine services, allowing healthcare providers to offer medical consultation and services to remote areas. It also supports remote education by enabling distance learning and e-learning platforms. Scalability. Satellite communication system can be scaled to accommodate increasing demand by launching additional satellites. This scalability is beneficial for expanding network capacity and coverage as required. Cost effective for certain application. For specific application such as broadcasting and connecting remote areas, satellite communication can be more cost effective compared to laying extensive terrestrial infrastructure. By using these benefits, satellite communication has become an essential part for global communication network, providing solutions that are difficult to achieve with terrestrial system alone. So, this way we have studied 12 specific advantage of satellite communication, that are wide coverage area, long distance communication, broadcast capability, mobility and flexibility, disaster recovery and emergency communication, global internet connectivity, redundancy and reliability, security and surveillance, scalability, environmental monitoring and weather forecasting, telemedicine and remote education, and last one was cost effective and certain application. Now, coming to the disadvantages of satellite communication. High initial cost. The cost of designing, building, launching and maintaining satellite is very high. This include expenses related to launch vehicle, ground station and ongoing operational cost. So, initial cost for launching a satellite is very high compared to terrestrial communication system. Then we see another drawback of satellite communication is propagation delay. Communication signal, we have seen in the example also, for geostationary satellite, the signal has to travel a distance of approximately 36,000 kilometer. So, signal travel a long distance to and form satellites, specifically those in geostationary orbit. So, this causes a noticeable delay, typically around 300 millisecond. So, this is the inherent delay of satellite communication. Apart from this, we have to apply all the effort to maintain this delay to this level. The delay should not be more than this. So, and this we have also experienced whenever you watch the television news channel, when a person sitting in the newsroom, when it tries to communicate with the person which is somewhere in the remote area. So, you visibly see there is a the person which is sitting in the remote area responded a bit lately. So, that is because of this inherent delay of satellite communication. Signal degradation, obviously when signal has to travel such a long distance, so and that too in a very harsh environment. So, signal get degraded. Atmospheric conditions such as rain, snow and fog can cause signal attenuation, leading to reduced signal quality and reliability. This is known as rain fad. Limited bandwidth. Obviously, bandwidth constraint is there in communication. So, that is equally applicable in satellite communication also. Satellite have a finite amount of available bandwidth, which can lead to congestion and reduce data transfer rate, especially during peak uses of time. Orbital slot and frequency allocation. This is there is a competition for orbital slot and frequency band, which are limited resources. Securing this can be a complex and lengthy regulatory process. Latency. The inherent latency in satellite communication due to the long distance signal must travel can impact time sensitive application, making it less suitable for certain real time operations. Security risks. The is very well known to us, whenever the data is in air. So, data is under threat in communication. This quotation is very well known to all communication engineer. Whenever the data is in air, data is under threat. So, satellite can be vulnerable to hacking, jamming and other cyber attacks, which can compromise the integrity and confidentiality of the transmitted data. So, this we will remember that whenever data is in air, so data is under threat. Then another drawback is space debris. The increasing amount of space debris poses a threat to satellite, potentially leading to the collision and damage, which can disrupt the services and require costly replacement. So, this is a nowadays this becomes a very crucial problem for satellite industries. Power consumption. Satellite requires significant power for transmission and operation, which can be a limiting factor, especially for smaller satellites. Complexity in design and maintenance. The design, launch and maintenance of satellite system are highly complex process that requires specialized knowledge and expertise, making it challenging to manage. Environmental impact. Launching satellite and the production of related components can have negative environmental impacts, including carbon emission and pollution. Nowadays, environmental becomes a very critical and crucial issue. So, this is another drawback of satellite communication. Regulatory and licensing issues. Navigating the regulatory landscape for satellite communication can be difficult, with various national and international laws and licensing requirement that must be adhered to. So, with this we have studied specific drawbacks of satellite communication. In total they are 12. First was the initial cost of the satellite that is required for launching of the satellite. Then we have come across the another crucial drawback of satellite communication, that is inherent propagation delay, that is approximately 300 milliseconds, that is always there. Inherent means always associated. So, 300 millisecond delay will be there. Then signal degradation, as the signal has to travel such a long distance in such a harsh environment, so signal get degraded. Then limited bandwidth, orbital slots and frequency allocations, again a drawback for satellite communication. Latency is a drawback, security risk, space debris, power consumption, complexity in design and maintenance, environmental impact, regulatory and licensing issues. Then coming to the last topic of this lecture session, that is applications of satellite communication. The first application of satellite communication is television broadcasting. We are using in our day to day life. DTH, direct to home. DTH stands for direct to home satellite TV. This DTH services provide television broadcasting to homes worldwide, ensuring a wide reach and high quality signal. Then all we are using is internet services. In our mobile we are using it. Satellite internet provides connectivity in the remote and rural areas where terrestrial internet infrastructures is not available or sometimes even not feasible. In that places it may be a very high altitude place or very difficult terrain. Everywhere from satellite we can have a internet services we can make available. Then weather forecasting. Meteorological satellite monitor weather patterns, track storms and provide data for accurate weather forecasting and climate studies. Again, application which is very beneficial for the human mankind or the society or for the nation as a whole. So, weather forecasting is very crucial application of satellite. Then another application in our day to day life we are using, that is GPS. GPS stands for Global Positioning System. Satellite provide precision location and timing information essentially for navigation in aviation, maritime and transportation. So, this is another very important application, that is navigation and GPS that we get from the satellite. Military and defense. Satellites are used for secure communication, reconnaissance, surveillance and navigation in military operation, especially the SS spread spectrum communication that is developed specially for tactical military requirement, where we want that enemy should not able to intercept our information, and on the contrary our military should able to intercept the military communication. So, for that SS communication and spread spectrum communication was developed, and satellite communication is playing a crucial role in providing that SS communication, which is able to satisfy the tactical attributes of military communication. Then another very crucial application of satellite communication in disaster management. Satellite provide crucial communication link during natural disaster, enabling coordination of rescue and relief efforts when terrestrial network are down, because whenever there is a disaster situation, so there is a obviously damage to the terrestrial networks. So, here the satellite plays a very crucial and important role in managing the disaster management. Remote sensing, a very key application of satellite, that is remote sensing. That is the strength of satellite. It is able to handle, able to cover, right, able to locate the remote areas. So, remote sensing, satellite captures high resolution images and data for earth observation, monitoring, environmental changes, agriculture, forestry, right. Whenever if there is a very bad situation, there is a forest under fire. So, that is told to the authorities by the satellite communication. So, satellite is helping in this way, right. So, environmental changes, agriculture, forestry and urban planning. So, these are the areas where the remote sensing of satellite is used. So, this is very crucial application of satellite and very important. Then another again very important is telemedicine, right, because expertise of the medical resources may not be available to the remote areas. So, here is the telemedicine which helps, right, patient to get the services of expert medical professional in the remote area. So, satellite communication enables remote medical consultation. In addition to that, remote diagnostic. In addition to that, nowadays certain major operations with the help of AI and robots, that the expert doctor can do it in the remote place. So, consultation, diagnostic and treatments that underscore the crucial operations also, that is now we are getting this kind of services in telemedicine, especially in isolated or under reserved areas. So, telemedicine another very crucial application of satellite that we are getting from the satellite communication. We are all using mobiles. So, mobile communication. So, satellite right, this is a very fantastic application right, serving throughout the world, right. It is helping the mankind in a way that we cannot even, is become the part of our life. Mobile is become the part of our life. So, satellite phones, mobile phones. So, mobile network ensures communication in remote areas, at sea or during emergencies when terrestrial networks are unavailable. So, we are using even in our day to day life this mobile communication. Broadcast radio. Satellite radio services provide high quality, wide coverage audio broadcasting, including music, news and entertainment. Then another crucial application of satellite communication is it helps in scientific research. Satellite supports space exploration, astronomy and other scientific research by collecting data from space and from distant celestial bodies. So, this way satellite communication helps in the scientific research, that is again very crucial for mankind. Then global connectivity for IoT. Now, all our life is slowly going to dependent on IoT, right, Internet of Things. So, this IoT requires global connectivity. So, here is the satellite which facilitate the IoT by providing connectivity for remote sensors and devices, enabling application in agriculture, environmental monitoring and asset tracking. Then another crucial area, banking and financial services. Again satellite communication here ensures reliable and secure data transmission for banking, transaction and financial services in the remote region also. So, another very important application of satellite communication in the banking and financial areas. Then corporate networks. Corporations are use satellites to establish private communication network for secure and efficient business operation across the different geographical locations. Then another very important area for mankind is education. Satellite communication supports the distance learning. Just a few years back we have seen a time of corona, right. So, that time we actually understand what is the importance of e-learning platforms and distance learning. Actually, the satellite communication take all the responsibility on its shoulder, right, to maintain the rhythm of education throughout the world in the duration of corona. So, no one can right, underestimate this application of satellite. This is a very crucial and very important. So, this way in this lecture we have seen around 14 specific application of satellite communication. It is internet services, weather forecasting, navigation and GPS, military and defense, disaster management, remote sensing, telemedicine, mobile communication, broadcast radio, scientific research, global connectivity for IoT, banking and financial services, corporate network and education. So, all these four different areas, right, that is very crucial, very important for mankind and the society or for nation as a whole. So, satellite communication is there to serve. So, in this lecture we have seen the certain advantages of satellite communication, drawbacks of satellite communication and the applications of satellite communication. Satellite communication right has a counterpart. Who is the competitor for satellite communication? Right, the fiber optic communication. Right. So, all the advantages and drawback of satellite communication are related to the fiber optic communication. Right. So, fiber optic communication is competitor to satellite communication. Right. So, whenever we say the satellite communication installation is easy, so it is easy compared to fiber optic communication. When we say satellite communication installation is difficult, so again it is difficult compared to fiber optic communication. So, all the advantages and drawback of satellite communication is compared with the fiber optic communication, that is wired. Today we are living in the age of wireless communication, but again we will remember these two, satellite communication and fiber optic communication. These two communication are initially competitor to each other, but as the time moves ahead, this satellite communication and fiber optic communication, they both are working as a complementary to each other. So, initially satellite and fiber optic were competitor to each other. Now, how they are working? They are working as a complementary to each other. Earlier they are competitor, now they become complementary to each other. The remote areas where fiber optic communication, fiber optic cable we cannot let down, that areas are covered by satellite, and the local areas are covered by the fiber optic. It is again said one line, who there are the many service provider for the mobile communication. So, which service provider is able to provide good services to their user? One who is having the good fiber optic network. So, this way, right, mobile communication is wireless communication with the aid of satellite only. So, this way we should remember that satellite and fiber optic are now working as a complementary to each other. So, that is all for this lecture session. Thank you.